Hello, everyone, and welcome to today's episode of the Health Path podcast. And I am speaking with Dr. Neil Nathan. Dr. Nathan is a medical doctor who graduated from the University of Chicago in the 60s and therefore has a huge amount of experience when it comes to supporting clients with chronic complex health issues. He's also the author of 5 books. You'll find links to these in the show notes, but they are called Toxic, Heal Your Body, Mold and Mycotoxins, Energetic Diagnosis, Healing is Possible, and On Hope and Healing. And within the book Toxic, Dr. Nathan details what this cell danger response is, which is the topic of today's podcast. Dr. Nathan explains to us what it is, what causes it, and some of the therapies and interventions that over the years he has found to be most helpful in supporting his clients. I really think this is one of the most important and helpful conversations I've had to date on the Health Path podcast. And I'm really excited about sharing this information with you and hearing some of the feedback and experiences that both practitioners and maybe some of our customers have had with this sort of approach. So without further ado, here is my conversation with Dr. Neil Nathan on the cell danger response. Dr. Nathan, welcome to the Health Path podcast, and thank you for sparing some time, and I'm sure your busy schedule, to come and speak with me today.
Thanks for having me.
So we were just saying off air that it would be great, and I think a lot of our listeners would really benefit from hearing you talk a little bit about a very complicated thing called the cell danger response. It's something that I think I first came across in your book, Toxic. And it really started, I had old clients come to mind where I was thinking, this really kind of resonates with maybe what was going on for them and potentially why they responded the way they did to some of the interventions that we tried. So, are you happy to introduce the cell danger response, what it is, and what we currently understand about it, I guess?
Sure, we can do that. And I don't want to intimidate the listening audience from the get-go, so I'll try to make it as relevant as I can from a clinical point of view.
Thank you.
Well, the cell danger response is the brilliant conceptualization of a physician named Robert Navio, who is a professor at the University of California, San Diego, who is one of the most amazing biochemists I've ever known. And he has been putting together a model of what creates chronic inflammation or chronic illness. So the cell danger response is his evolving understanding of how that occurs. So what he gives us here is a absolutely remarkable model of almost all chronic illness, about how it comes across biochemically. And in its simplest terms, what happens in the cell danger response is that on a cellular level, the mitochondria, which we all know as the energy-producing little organelles inside of every cell, now, that is one of their main jobs. But what's often not recognized is that the mitochondria also have a protective component to them, in that they sense the environment of the cell. And if there's a drop in voltage of the cell, which can be created by 3 main things: toxins, infections, and stress, sometimes combinations of those. But if the stress or the toxin or the infection is serious enough, the mitochondria will react by beginning to go into this cell danger response. And that cell danger response is basically protective. We have had this for millennia. This is something that has been with us as humans evolved on this planet. And it's very primitive in the sense that we are shutting down intentionally a lot of our chemistry to limit the infection or the effect of the toxins or the effect of stress. So, as an example, If you had a viral infection, the mitochondria sense the invasion of the virus into that cell, and immediately goes through a series of orchestrated biochemical events. So some of those include, for example, shutting down methylation, which we know is a very, very important process. There are hundreds of reactions in the body which require methylation. Just for example, we make melatonin out of serotonin by just methylating serotonin, and on and on and on. We methylate to detoxify. We methylate to heal DNA that is broken or damaged in the cell. We require methylation for literally hundreds of very important reactions. But viruses can't replicate without methylating, and they don't have the capacity to methylate. It's not in them. It's just a virus. It doesn't have the elaborate biochemical machinery that we have. So viruses have to hijack our ability to methylate in order to duplicate or replicate themselves. So we shut it down. Now that's great initially, but if that cell danger response doesn't quiet down, then we are not methylating for a prolonged period of time, and that becomes part of the problem, not necessarily the solution. The same is true with literally dozens of other biochemical reactions. How we utilize tryptophan to make serotonin, or it goes down a different pathway to make kynurenine, which is an inflammatory product. And literally, Dr. Navio has laid out in his model dozens and dozens of biochemical reactions which are unique to the cell danger response. So that's our chemistry. And again, it's protected in its essence. However, if we don't take care of the infection, if it persists, if we have a toxin which we are not able to get rid of, mold toxicity being a very good example of that, or if we're under a prolonged degree of stress, as long as the cell biochemically knows itself to be stressed, it is in danger, and it can't heal until that threat is neutralized. So that's the basic essence of this. Now, where this comes into play, especially from a clinical perspective, is if you have a major infection, say Lyme disease, which I know people in the UK say doesn't exist, and I will tell you categorically, it does exist, and it's a serious problem there, which the medical authorities have not really recognized. Or if you have mold toxicity, which is something not very well known in the medical profession, but I can assure you, in the UK, a land of old, musty, damp buildings, I'm sure mold toxicity is rampant in the UK. And stress, we all have that to varying degrees. So those three things, if they persist, will not allow the body to respond to the treatments we might otherwise give. I'll give you some examples of how that comes into play. A lot of our patients who have been chronically ill for a while, their practitioners will evaluate them, run tests on them, and go, you have mitochondrial dysfunction. Like that's a diagnosis. Forgive me, that's the whole essence of the problem. That's not a diagnosis. It's a description of what's going on. And then people will give you, practitioners will give you supplements that supposedly would help mitochondria to work better or to function better. Now, if we're not in extreme danger, those supplements will work great. But if we are in a danger response, they won't work at all, or they'll make us worse. And so a practitioner will scratch their head and going, I know your mitochondria aren't working well. You're fatigued. You have post-exertional malaise, which is classical for mitochondrial dysfunction. I know you have it. How is it that you're not responding to it? And the answer is, if you understand the cell danger response, the patient will not be able to respond to it under most circumstances until we've addressed the infection, address the toxin, and address the stress. To the adequacy of the cell. This is not a psychological issue. It is not like convincing ourselves, oh, I'm really better than I think I am. I'm not in as much danger as I think I am. On a cellular level, the mitochondria will know how sick you are. There's no psychological component to this at all. So the same is true of methylation, which I mentioned before. A lot of my patients are told, "Oh, you're not methylating properly," and they'll give you the supplements we use to improve methylation. And they not only won't work, they'll make you worse because that's not what the body wants at that point. So it's very important to try to understand where the body is vis-a-vis its safety. And that is the key to a whole lot of things that are just beginning to be understood right now. One more example would be a lot of patients who come to see me are told that they have Epstein-Barr or another common virus like HHV6. And, and they have lab tests which show that they have been exposed to Epstein-Barr. Not necessarily that they have it now, but they've been exposed. And the practitioner goes, "Oh, you poor dear, you have Epstein-Barr, and I'm going to give you the things we use to treat that." And again, not only won't they work, that's not the infection that is triggering this. There is something that is weakening that immune system, making them an opportunistic infection or a latent infection resurface. But treating the Epstein-Barr, which some of my practitioners have done for years, making no progress because they haven't identified the actual infection that's triggering it or the toxin. So that's what's important.
Yeah, and I mean that brings up so much ultimately. I think trying to go back to the beginning of that introduction, you talked about sort of cell voltage, which is going to be, I think, quite a new concept for some people. Is there anything that you can just expand on from that perspective?
Um, I can talk about it in more detail, but I think I'll lose some of your audience here. When the cell voltage drops caused by a toxin or an infection, the mitochondria go into this cell danger response. So one of the first things they do is they change the oxygen content of the cell, and that changes the chemistry of that cell. The cell no longer works with large molecules, nutritional molecules. For example, um, the metabolism of the cell becomes very primitive. It works with simple sugars, simple amino acids, and it can't do the complicated work it does with fats and proteins that it normally does. One of the things that occurs, and this is quite important, is that because of the shift in the redox potential of the cell, the way we detoxify changes dramatically, so that normally our exposure to heavy metals or other toxins we handle quite well. But when that happens, the body starts to sequester heavy metals and is unable to remove them. So again, a lot of people will measure heavy metals and go, "Oh my goodness, your real problem is heavy metal toxicity." Where no, I'm just not able to detoxify what's in me. If you fixed what was wrong, I would be able to improve my ability to detoxify and I'd get them out of my body. So again, the vast majority of people, if we measure it, will find excess amounts of mercury or lead or things like that, which of course that's not good for us, but we're not identifying the key root problem that we want to be getting to. So I hope that expansion adds to our understanding here.
Yeah, absolutely. And I guess would I be right in saying that when you talk about sort of infections and toxins like mycotoxins and how they can be one of the, I guess, the root drivers of the cell danger response, that we're kind of talking here about when our natural body's ability to deal with these things has been exceeded, there's almost a switch that goes on, which then means that we've got this more chronic issue.
Exactly. And the underlying issue with these chronic problems is almost always an inflammatory response that the body is unable to get under control. So we're dealing with an inflammation, and chemically, this means the pro-inflammatory cytokines of the body are way out of control, and the immune system can't bring it under containment. Its normal mechanisms or methods of quieting that inflammation doesn't have it. It just can't do it. So that's why toxins and infection, even though they're very separate causes, they create a inflammatory response in the same way so that you'll get similar symptoms from toxins and infections because they're creating the same type of inflammation.
Okay. And you mentioned a few things there around or earlier with, for example, methylation. And although I'm sure there's more than one cause, are we therefore saying that if someone does seem to be reacting to methylated B vitamins, for example, that this is kind of an area that we might want to then start considering, I guess?
Well, yeah, if you have a patient who is not responding in the usual way to what you're giving them, by definition, this means you haven't got the right diagnosis. You're not helping that body the way it wants to be helped. Now, the bodies are very intelligent. They know what they need, and they try to communicate to us. They give us symptoms. Now, we don't like those symptoms. We think that's the issue, but it's not the issue. It's how do we listen to that so that we correctly interpret what our body is trying to tell us. Our bodies don't want us to feel lousy.
Mm.
They, they just want to say, hey, wake up. You have a problem here and you're not dealing with it appropriately.
Mm. Okay. And I guess in regards to this, therefore, where are we at in regards to this evolutionary process? And what I mean by that is at a clinical level, are there any ways of sort of evaluating the cell change response, I guess is my question? Or is it more that we're going after and exploring, is there Borrelia there or is there mycotoxins, etc.?
There are several answers to that question.
Okay.
So, so first of all, part of the brilliance of Dr. Navio is that he has spent the last 15, 20 years developing the science of metabolomics, in which we can measure hundreds of metabolic um, chemicals in the body with one blood draw, with a single tube of blood, using a mass spectrometer and flow cytometry. We can measure hundreds of them accurately, so that what he's been doing is to try to take certain medical conditions and map out the biochemical changes that those conditions cause. So although the inflammation may be the same in all of them, the actual biochemical shifts vary. And Bob has taken, for example, I did a research project with him on chronic fatigue syndrome, where we took a large group of patients with chronic fatigue, equally matched males and females, and we measured the difference between normals and controls and the biochemistry of chronic fatigue. And we discovered that in males, there were 8 specific metabolites that if they measured low, this was a clear diagnosis of chronic fatigue syndrome. Now, for years, a lot of chronic fatigue patients have been told this is in your head, there's no such thing as chronic fatigue, and they've been told incorrectly, which is no, this is a biochemical issue. This is very real. It's not in your head, and we can now measure it with a single blood test. We can separate with an accuracy of 92%. We can tell the difference between someone with chronic fatigue and a control based on looking at their chemistry. And with women, using 11 different chemicals, because women and men turn out not to have the same differences in chronic fatigue, with an accuracy of 96%, we can separate that out. And what I'm very proud of in that paper that we put together is that for the first time, we're making it very clear that chronic fatigue is not a psychological issue. It is a biochemical issue, and we can measure it and we can prove it. And so, okay, what is creating that biochemistry and how do we then treat it? And we've been working in the chronic fatigue world for 25 years and helping thousands of people with chronic fatigue, while the medical profession kept saying, no, this is in your head. So forgive me, but it's very frustrating that my profession has not picked up on the research that we've done and the work that's been done to clarify.
Yeah, absolutely. And I think, that level of accuracy is phenomenal, really.
Right. And he's also worked on um, traumatic brain injury, depression, Gulf War syndrome. Most recently has worked on Lyme disease. So he has a scatter pattern, if you will, where if we do that test, I want to come back to the testing. If we do that test, we can begin to even know what the diagnosis is based on the biochemistry that's out of whack. Now, unfortunately, that test is a research tool right now. It is not clinically available, but I know that a number of labs in the States are actively working on making that test clinically available. It will only be a year or two before that test will be available, and patients will be able to begin to have their illness put into a known arena. Now, unfortunately, it's very expensive doing these studies, and Dr. Navio has always been privately funded. Our NIH has never, in its infinite wisdom, decided to fund it, which of course they should be doing. So until more of these are done, we won't have a complete pattern to compare to. And by the way, he's also done that work with autism, and I probably should talk about his work with autism because that's spectacular. So again, all of these patterns are different from one illness to the other, even though in many cases the symptoms are very similar. So Dr. Navio has taken the cell danger response many steps further, and he's realized that you can begin, once safety is beginning to occur, you can speed up the healing process by blocking what we call the purinergic receptors in the cell. Now that's a fancy term. Purinergic means purines, and we're really talking about ATP, which is the main energy generating molecule in the body. Now, yes, ATP does that, but also it is a signaling molecule. And often people don't realize that. So when that mitochondria is aware that it's danger, instead of using the ATP, it releases ATP out of the cell to warn all other cells, oh, danger, danger, and the extracellular ATP, the ATP that's released by the mitochondria here, are the signal. So Dr. Navio reasoned, can we turn off that signal? And it turns out that we have 19 purinergic receptors in the body, which are simply receptors that are on the cells of the body that actually monitor the, the, the safety level in that cell. And it turns out there is one medication called Suramin, which can block it. So what Dr. Navio has done with autistic children as a model is he's done a study in which he's taken a number of autistic children and a number of autistic controls, and he gave them one dose of intravenous Suramin, which is really quite benign. Unfortunately, it's not available. I know people are going to immediately go, well, where do I get Suramin? At this point, you don't. It's made by Bayer in Germany, and they have shut down their factory, ostensibly building a new one, not releasing it to the public. So other than for research purposes, you can't get Suramin. But when Dr. Navio injected those children with Suramin, he has videos of this. They went from being the non-functional children that you will see in autism with tics galore to being able to talk for the first time in years and make eye contact and share. And the videos that he's made of those, which are available on his website, are spectacular, in which you can see an amazing improvement in autism almost immediately on getting a Puramin purinergic receptor blocker like Suramin. So there is a company in South Africa that has begun to make Suramin on its own and do some of this research. And their preliminary work is certainly mimicking Dr. Navio's, meaning, yes, they're finding the same thing. As their company goes up, maybe we'll have Suramin as a way to help reverse the cell danger response. But I want to have this is not the magic bullet. Yes, it works. But remember, it won't work until the mitochondria feel safe again. And you can't trick it into feeling safe by blocking the receptors. You still have to find the toxin or the infection that's triggering it. Then, once that treatment is underway, then I think Suramin will be a godsend for all of us.
Okay. So I want to come back to this theme of safety in a second, if that's okay, Dr. Nathan. But beforehand, if I try and really briefly summarize this, we're kind of saying that someone is going to be exposed to an organism or a toxin or a potent enough stressor that is going to essentially shift cellular metabolism. Mitochondria are going to feel that sort of lack of safety, which then initiates the cell danger response. One of those mechanisms, because I know there are many others as well, is ATP being spilt out of the cell, which then kind of perpetuates this sort of inflammatory sort of response. A little question before I continued the summary, because otherwise I'm going to forget. Is this kind of the same concept of ATP being a damage-associated molecular pattern that then triggers that sort of inflammatory response, or is this slightly different?
It is. I think you can put it into the damp category.
Okay. And then ultimately, we both need to deal with the underlying issue, which would be detoxing someone of mycotoxins or dealing with Borrelia or whatever it may be. And I guess if someone's still struggling with the same cluster of symptoms, we would then start thinking that actually the cell danger response is keeping people stuck, and there is that sense of a lack of safety still.
Correct.
Okay, awesome. So with that in mind, I know in your book you talk about the polyvagal theory and how it kind of, there's a bit of ebb and flowing between that and what you've been discussing so far. So unless you think there's a better direction for us to go in, would you mind just kind of introducing this theory and how it does kind of interconnect?
Sure, and that's a good segue. So I want to talk not only about polyvagal theory, but also about limbic dysfunction and mast cell activation. I kind of have to talk about them all in the same breath,
Okay.
which would be very difficult because it would be a very long breath. Because here it is, here comes safety. So we've talked about the biochemistry of safety, which is perpetuated by the release of ATP by the cells. And they keep releasing ATP until, because they keep wanting to warn the rest of the body that we're not safe until safety has occurred. But safety can also be understood on other levels. So on a cellular level, mast cells have a lot to do with safety, and I'll come back to that in a minute. And on a brain level, there are two areas of the brain that monitor the body for safety. And those are the limbic system and what we call polyvagal theory, or what I'll call the vagal nerve complex. Because it's not just the vagus nerve, which is the 10th cranial nerve, but a number of other cranial nerves. And the vagus nerve is a key player in the autonomic nervous system. So we're really talking about the autonomic nervous system and the limbic system as monitors and regulators of safety in the body. Because if they don't think we're safe, as per the cell danger response, our patient isn't going anywhere. And the longer an illness or an inflammatory illness persists, the longer someone goes without a diagnosis of a toxin or an infection, the more likely it is that the limbic and vagal systems are going to be affected and become part of the problem, not the solution. So this is really important because in many patients who become chronically ill, they are unable to respond to the supplements or medications that we want to give them because they don't feel safe. Again, not psychologically, but on a neurological basis, that limbic system and vagus system, both of which work together very intimately. Although they're separate parts of the brain, physiologically, they're out there scrutinizing the stimuli that we are exposed to, both internally and externally. And if either system doesn't think we're safe, they will shut us down with symptoms that will go, the symptoms are to get our attention to go, you're not safe, pay attention, be aware. Now, we don't like those symptoms and we thought, why is my body betraying me? It's not, it's doing its job. So these three systems probably warrant a much longer discussion, which we can now have.
Brilliant. So, yeah, where would you like to take it from here then, Dr. Nathan?
Any three of these need to be talked about, but the point that I really want to make is all three systems are interwoven. The vagus and limbic areas profoundly affect the mast cells, which are an immune cell that is present in every tissue of the body, but particularly present in the cells that line the outer surfaces of the body, which makes sense because they're out there monitoring the safety of those outer surfaces for, are there toxins or are there infective agents that are coming down through the sinuses or the gut that I need to be aware of. And if they don't think we're safe, they become, a word for it we use is activated. And a word that I would use would be reactive or hypervigilant. And the same words could be used for the limbic and vagal system. So when those mast cells, I guess I'll start with mast cells. When those mast cells become activated, anything that touches or connects to them can trigger a reaction. So let's talk about it clinically for a minute. A patient who has mast cell activation may find that either while they're eating or immediately afterwards, they will all of a sudden have a release of histamine and 200 other biochemical mediators that can affect them. And so we're all biochemically and genetically unique. So your symptoms might be gas, bloating, abdominal pain, sweating, tachycardia, brain fog, fatigue, sinus drainage, immediately on eating. But it will be confusing because you can eat a particular food one day and it seems like it set it off, and you can eat the same food the next day and it won't. And so it's like if this was really food allergy, I really ought to be reacting to the same food the same way every time, and you don't. So it looks like allergy, but it's not, and that's what we call mast cell activation. The issue is it depends on how activated the mast cells are at the moment that you eat. And for example, with mold toxicity, the levels of mold toxin in the body fluctuate. So sometimes when the levels are higher, the mast cells will be activated, and sometimes when they're lower, they won't be. And so we can understand why you might eat the same thing one day and react to it, and the next day you wouldn't. And these symptoms are classical for mast cell activation. So again, the key is identifying that it is going on because it's treatable. And I want to tell our listening audience that every single thing I'm talking about today is treatable. So I know that it could be scary to talk about all this stuff, but all of it's treatable. So we can quiet those mast cells by giving a variety of medications and supplements. But if we really want to quiet the mast cells, we also have to concurrently and simultaneously quiet the limbic and vagal systems also, because each is influencing and affecting the other. So sometimes people who aren't aware of that will go, well, I've treated my mast cells, but I still can't get them well. They still react and they're not getting better. It's because your body still doesn't feel safe, and we have to work on it from other perspectives also. I hope I'm being clear.
Yeah, I think, and just to, you did mention it, but to reiterate to some of our listeners, when you talk about mast cells being on the sites for the outside of the body, we are, as you mentioned, talking about the GI tract, obviously, because that's the hollow pipe going through us. But just to clarify one thing, are you therefore saying that mast cells and these hundreds of mediators that they can produce, can that trigger, um, you mentioned it can trigger like anxiety, for example. So it can trigger what might feel like more of a psychological thing.
Yes,
The
yes, very,
okay.
yes, very profoundly.
Mm.
So um, each affects the other. So if we talk about the other systems, the limbic system is the part of the brain that monitors, regulates, and controls two main things: emotion and sensitivity. So as the limbic system becomes more and more affected by either infections or toxins, that limbic system becomes more and more hypervigilant. And the symptoms that we would see are the symptoms that would be regulated by that part of the brain. So they would be anxiety, depression, OCD, um, depersonalization, derealization. Um, all of those things can be triggered, or if someone has some tendency to them already, worsened by the fact that the limbic system is now involved. The limbic system is also involved with the perception of sensitization. So sensitivity to light, sound, touch, chemicals, food, and EMF, all of that is limbic. So if a patient didn't have those things before, but begins to develop it, what we know is that, okay, you have some condition that has not yet been diagnosed that is triggering this. And if we're going to get you well, the first thing we have to do is to bring your limbic and vagal and mast cell systems back under control. Okay. So that's the limbic piece of this, and it's very profoundly affecting emotion. If someone has not been prone to anxiety or depression and kind of develops later in life, think think it limbic immediately, and then go back, well, what's triggering it? So think things like mold and Lyme, because they're profoundly important in people who have a lot of anxiety, depression, and OCD. And it's a misdiagnosis that is eminently treatable. You can band-aid it, you can cover it up with medications, and you'll feel a little bit better, but you won't cure it. But you can cure it if you get the mold out of their body or treat the Lyme disease or the Bartonella. So that's why it's really important to understand that. Then if we factor in the vagus system and its connection to the autonomic nervous system, now its symptoms are a little different because the vagus nerve controls, for example, intestinal motility. So anyone who develops gas, bloating, constipation, maybe the vagus nerve is not allowing the intestines to function properly. So all three systems, and I guess I'm emphasizing it, I can't do it enough, need to be looked at concurrently in patients who've been ill for quite some time, because what may be keeping them from moving forward and progressing is that we're not looking at that.
Mm.
And honestly, I see hundreds and hundreds of people where the practitioner isn't aware of this information. And in fairness to them, this is fairly new information. Um, we didn't know much about mast cells until Larry Afrin wrote his book um, on Occam, 2016. And it's now gone from being almost never talked about to there's a summit on it every day. And now it's a hot topic in medicine. And Stephen Porges' understanding of polyvagal theory, Steve proposed that in 1994. And it is only in the last few years that people going, wow, the vagus nerve is really important. And it's really non-functional in a lot of people. And the same thing's true of the limbic system. So we're just beginning to grasp how interwoven and important these systems are in determining our health and our ability to heal.
Amazing. Okay, thank you, Dr. Nathan. That's yeah, I've got lots of light bulbs going off at the moment. I
Okay.
guess from the mast cell perspective, and we're thinking of some of the stimuli that can either degranulate or just activate the mast cell. We've covered bits of that in regards to thinking about some of these exposures that we can have. What are some of the things that we can consider, I guess, from a limbic and polyvagal perspective? I'm thinking of things like DNRS maybe for limbic dysfunction.
Absolutely. The two main systems that I've used for years in treating the limbic system is, and you mentioned it, the DNRS system developed by Annie Hopper. DNRS stands for Dynamic Neural Retraining Systems, and it's a method for literally retraining the limbic system. Remember, it's not psychological. You literally have to reboot the nervous system. The other excellent program by one of your countrymen, Ashok Gupta, is the amygdala retraining program that he's developed, which is also excellent. So I almost always recommend one of those two programs as a starting point. For the polyvagal theory, there's a number of excellent methods that we use to treat it. There are some exercises that have been developed by a Danish craniosacral therapist named Stanley Rosenberg, and an excellent book that he wrote, Accessing the Healing Power of the Vagus Nerve. He developed those exercises to accompany good quality cranial therapy so that osteopathic cranial work is a wonderful tool for quieting the vagus nerve. There's a medical device called frequency-specific microcurrent, which is great for that. There's another medical device called Brain Tap, also great for that. And now we're beginning to get a number of vagal nerve stimulators on the market that are increasingly showing to be super important in this process. Just yesterday, a friend of mine sent me a paper on the interrelationship between inflammation and the vagus nerve. And it's just now being realized that the vagus nerve, in addition to its normal connections to the gut, the heart, and the lungs, and the other tissues, also has branches to the thymus and the spleen and to the galt, meaning that it directly influences our immune system's ability to regulate inflammation.
Wow.
So and my friend turned me on to a couple of papers that I read just yesterday showing some brand new research that inflammatory bowel disease like ulcerative colitis and Crohn's disease, a physician just did a small pilot project showing in 22 patients who had that most of them could go into remission by stimulating the vagus nerve as their primary treatment.
Wow.
Meaning so when the vagus nerve is dysfunctional, it is profoundly connected to our inability to regulate inflammation, which is the underlying cause of all of this. So again, we're seeing all of these interrelationships. The mast cells are directly connected to the vagus nerve by their nerve endings, that the majority of mast cells actually touch the vagus nerve branches. So again, all of this is interconnected. And the beauty is, I think for the first time, we're beginning to understand it, and we have the tools to treat it effectively.
Yeah, I mean, that's fascinating. And I think one of the things that comes up time and time again when I speak with people is how rare it is, if it ever happens, really. Well, I'll go with rare for now and see what your opinion is. That the body doesn't do anything by mistake. Like there is normally a deliberate reason why it's shut down methylation or whatever it may be. And we just need to unpick it until we get to that actual stimulus.
Yeah, exactly.
Amazing. Okay. It feels like we've covered an awful lot there, Dr. Nathan, and it felt like that was almost a conclusion to this three-way piece that you've just
Okay.
been touching about. However, you know more than me. So is there anything else that you want to share in regards to any of that that we've just been speaking around?
Well, I think this discussion wouldn't be complete if we didn't talk about the causes. So we've talked about the biochemistry and the neurology, the immune systems component and all of that, so that I hope that our audience begins to understand how this is all interconnected. But from a practical point of view, we still have to come back to what were the infections and what were the toxins. So I really want to comment on, first of all, mold toxicity is epidemic. It's been estimated that in our country, 10 million Americans are currently suffering with mold toxicity. Most of them don't know it.
Mm.
And I can't extrapolate to the UK, but I know it's common.
Yeah.
But the problem is the vast majority of physicians in the UK know nothing about it. In fact, what most doctors will do if they don't know much about something is go, well, if I don't know about it, it doesn't exist. Because if it was something important, someone would have taught me this already, which is a bizarre way of thinking. I don't understand it. It's kind of like, you mean nobody's ever discovered anything new that I don't know about since I left medical school? Really? But that's, believe it or not, I get that argument a lot, which is if this was really true, someone would have told me about it already. You can't be the first person to be telling me about this. Again, I'm mind boggled by that method of reasoning in the same way that until yesterday, I didn't know about the vagal connections to the immune system, which is profound and very important. Okay, I learned it yesterday. Before that, I didn't know it, but now I can see how important and relevant it is. So forgive me, but my profession is not very good at picking up on new information. New technology, new drugs, yeah, they're economically driven. New information, not so much. So what I really want to leave our listening audience with is mold toxicity is extremely common. And if you have an undiagnosed illness, which involves inflammation that would affect virtually any organ system in your body, it can affect your psyche in the form of anxiety, depression, cognitive impairment, not being able to think clearly, headaches, joint pain, muscle pain, intestinal issues of every sort, neurological issues, peripheral neuropathy, shortness of breath, and so on. If you have a complex medical issue and it hasn't been diagnosed, think mold or another toxin, although mold is probably the most common. And also think the possibility of Lyme or Bartonella, which also cause these same systemic inflammatory issues. So I just want to emphasize it's not enough to understand this. We still have to make the body safe by treating what's making it sick. And I know that there are only a handful of physicians in the UK who are doing this kind of work. So my hope is to encourage or stimulate more physicians to learn this so that they can help more people.
Yeah, absolutely. And I guess is there a caveat to this, which is, and certainly with the examples you've given, they would have to have likely done some form of treatment previously. But like you've said earlier, it's possible that someone's cleared the infection or the toxin, but is then stuck in this state. But for that to have happened, that most of the time they would have had to have gone through a pretty specific, thorough protocol, and therefore you would get a sense of that's what's going on, I guess.
Now, in fairness, most people, I treat a lot of mold and Lyme disease, no shock. If you treat them successfully, the majority of them will automatically reboot,
Okay.
meaning their immune systems will come back online. They'll get their latent infections under control. They don't need to treat their Epstein-Barr by profoundly improving the functioning of their immune system, their bodies will do what they were designed to do, which is to work well. But we will see occasionally someone who is still stuck. They will often be in the category of, although we've eliminated the infection, the limbic, vagal, and mast cell systems haven't gotten the message that we're safe yet. So if we then do that rebooting process, almost always they will feel safe and they will go back to functioning normally. So the vast majority of people that I've worked with have gotten well.
Okay. And that actually reminded me of something that it was in a newsletter you wrote, and I want to say it was potentially in 2018, so it's a while back. But you kind of discussed, I think, through your reading, how sometimes people might feel worse. And that might be because or related to the cell danger response, this idea that their normal is actually um, an imbalanced diseased state, so to speak. So as they start to shift away from that new sensation somatically, physiologically at a cellular level might actually lead to what we initially might have said was like some sort of die-off reaction happening, but actually could be part of this process. Is that still, you still think, a factor?
Oh, I do. That's one of Bob Navio's brilliant insights, which is the body gets used to where it is metabolically, if you will, habituated to it,
Mm,
even if it's not very good. It's like any bad habit you have. Um, sugar's not good for you, but you just can't help eating that particular candy that you just love so much. You literally get addicted to it. Well, literally, we can be addicted to our own chemistry, which is this is what my body is used to. And as that improves, the body may freak out and go, "Oh my God, I don't know what to do with that." Even though it's healthier, even though ultimately it would lead to us getting well, it is a very real phenomenon that we may react to treatment that is helpful by being worse briefly. And
mm,
so sometimes people mistake that for what we call a herx or a die-off or um, a reaction to the treatment that, as I said, is helping, but the body goes, I don't think it's helping. I feel worse right this moment. Um, and so this adds another level of complexity to what we need to do as clinicians in terms of looking at our patients' reactions. Are they reacting to something that I'm giving them? Or is this something that if I keep supporting them, they will get well because they just have to kind of, you know, build their way through it?
mm.
And, and that's a very complex, difficult question to answer for
Yeah.
which we have no lab tests. This is where clinical judgment comes in.
Yeah. And I'm guessing to some degree there might be some truth to the idea that the more hyper vigilant that immune system and nervous system is, the more likelihood it is that as they shift out of that metabolic state, that system's just going to go, whoa, this is not familiar, and
Right.
mount that sort of response, which actually aligns with the research from HeartMath Institute. They have a similar thing from their lens, which is the body and the body seeking familiarity. So it will unconsciously draw you towards things to maintain that state that you're in, because although it might be causing distress in some ways, it's familiar. It's what you're used to. So it's really interesting that from very different perspectives, people are saying similar things.
And I think you're saying it very nicely. It would be very similar to being in a difficult relationship with someone where you know our marriage is not doing very well. We go to war every night. We fight about everything. This is highly unpleasant. But both in the couple are afraid to do anything about it because I don't want the unknown. I know this known. It may not be pleasant, but maybe it would be worse if we
Mm,
fix this. Now, generally, that's not true. Generally, if you fix things, you open up the possibility to a much happier life. But that's not how human beings operate. You're absolutely correct about we know the familiar. And that is your description is really spot on.
Okay, good to know. And my final question, I think, that came to mind when you were sharing something earlier was, do you think this could be a potential additional explanation as to adverse childhood events and disease in adulthood, where we've got that really good correlation in the research?
Oh, absolutely, and I don't think there's any question about it. I would take might into yes, it is,
Okay.
because as we grow up, I mean, none of us have perfect childhoods, some better than others, but those who are exposed to more abuse, be it verbal or emotional or even sexual abuse, or have multiple surgeries, or have parents who divorce and under difficult circumstances, that each successive trauma profoundly affects the limbic system's perception of safety. With each successive trauma, we go, oh my goodness, the world I'm living in isn't very safe. I have got to be more and more vigilant about my my world and the stimuli in my world in order to protect myself so that I'm safer. And with each successive event, our limbic systems are more and more hypervigilant, so that by the time that we get Bartonella or get mold toxicity, we already have a limbic system that is on the edge. It's not really comfortable, and it goes, now we're really inflamed, and it went whoo. Now we're off to the races. So yes, you can readily understand that early childhood experience, which are difficult or negative, profoundly affect what happens to us later on.
Yeah. Which brings me to my final point, which is it's another example for me. I kind of view these things as it's all accumulative over a lifetime. I guess it's the exposome concept, really, which goes back to what we said earlier, which is our kind of, I guess, our state of health at the time of that exposure is going to have such a vast impact on how we respond to the exposure. Do we have the resources to deal with it, or actually do we end up in a negative snowball effect where we could end up with the cell danger response, so to speak?
Yes, but the way I've looked at it, having practiced medicine for over 50 years, is that all human beings have a choice. Now, we don't always make good choices, but we have a choice. We can either look at our situation and go, I don't care what it takes. I'm going to be safer, and I'm going to heal my body, and I'm going to get well so that I can really enjoy what life I have. And or we can go, why bother? Why try? I'm miserable already. I'll just stay miserable for the rest of my life. And I've seen that throughout my stay in medicine, that you look at people and some will go into a hopeless mode, and some will go, oh no, I'm a fighter. This is unacceptable to me. And so, as human beings, all of us have the option and the choice and the right to go, unacceptable. I'm going to fix this. I will find a way. And my message to everyone is, yes, you have that choice. And if you make that choice, you're upping the odds dramatically that you will indeed be able to have a much more pleasant, enjoyable, wonderful life. So make that choice.
Yeah, brilliant. Dr. Nathan, thank you so much. It's been, I'm really excited to share this episode. And I think I can just think of so many people over the years that if I just had that knowledge back then, I could have maybe helped them along a different path. So I'm looking forward to this conversation being there for some practitioners where I was maybe a few years ago as well. So thank you. It's been a real pleasure to speak to you.
Thank you. And I too wish I knew then what I know now. But, we take it from where we are in space and time, which
Yeah.
is, I do know this, and I'm happy to be sharing with you what I've learned, because I do think that this invention can help thousands and thousands of patients, um, and the physicians who treat them to do understand what's going on and be able to help them in a more profound way. So thanks for giving me this opportunity.
My pleasure.